A pi tag, it's basically a unique storage place in the pi server for a specific stream of data. In fact, you'll hear sometimes used interchangeably with the term data stream. But in fact, a pi tag is where we would store, for example, the flow rate from a flow meter, or if you've got a controller, the mode of the controller is stored as a digital string, then that would be stored in a pi tag. Other examples of tags, for example, the batch number that's associated with a product when you're doing event tracking using our batch system. If you've got some operator comments that you'd like to store on the pi server, we do that through a text tag. The results of a calculation. Those are all things that would be considered pi tags. Let's take a look at a tag. Here's graphically what a tag would look like. I'm looking at 3 tags here, and if I zoom in, I can see this represents real-time process data. So the fundamental unit of pi is known as a tag. Sometimes you'll hear it called a point as well. Now, if you chose that you would like to create the default pi points, then you'll notice there's a series of tags with unique names like sinusoid and CDT158 and this CDM158. There's a whole series of about 10 or 11 tags that you'll find you kind of get by default, and those are great tags to keep around for testing purposes. As I've mentioned before, if you're having, for example, problems with your OPC interface and you think it might be an archive problem and not an interface problem, simply check to see if the values of these tags are changing. If the values of these tags are changing, then you know what you have is probably some kind of an interface problem and not a problem with the archive, since the test tags are working. Every pi tag belongs to a point class. The point class is going to identify how many attributes that particular point supports. So all pi tags support the base attribute set. The base attribute set's a series of these 39 attributes, and they're very simplistic things like the name of a tag, the 0, the span, the engineering units, things like that. Now, in addition to those attributes, we also have other attributes that are required for different purposes. For example, if you're getting your data in real time from a control system, like the vast majority of pi tags are, then there are going to be some additional attributes, what we call classic attributes. Now I'm going to go ahead and retrieve a set of classic attribute tags. And I'm going to use the Pi system management tools to do this. So let me go into Pi SMT. I'll choose to import tags. We'll be going over this later on. And so for the point source, I think what I'll do is I'll look at all point sources, and I'll look for all the pi tags that begin with the letter CD. I'm just going to bring in all attributes for this. Now we're going to look just at a point class called classic, and these are the different types of points you can have. I'm just choosing classic, and as you can see, this has brought in a small number of tags, 3 tags, and each of those tags has a series of attributes. So these are, some of these are base class attributes, some of these are classic attributes. But these are the types of attributes that you're going to see when you start building pi tags. Okay. Things like the span and the 0 that's associated with a tag. Those are the attributes. And as I mentioned, every pi tag has all these 39 base attributes. Now beyond the 39 attributes, it really depends on what the purpose of that tag is. As I mentioned, for gathering real-time data, we have classic attributes, and we'll look at those one at a time. We also have specialized tags such as totalizers, SQC alarm tags, regular alarm tags, and these have the base attributes plus a variety of other attributes. In this case, 18 for the totalizer, 26 for SQC, and alarm has another 22 attributes. So at this point, I'm going to go through a series of the attributes and just describe the attributes briefly. First of all, every pi point has a tag attribute. Tag is simply the name of the point. So it does have certain constraints. As we see here, first character must be a letter or number. They must be unique on the server, and we don't allow any control characters. These characters that you see right here, those characters are not allowed. So any of those characters, it's just going to object to that. Also, we do suggest you avoid the underscore. The underscore, not a good idea, because if you are making use of any of our SQL query tools, like the ODBC support or OLADB support, you'll notice the underscores may run into problems when passed to those types of applications. Another attribute is the descriptor, and a third is the engineering units. Fairly self-explanatory. These are obviously spelled exactly as shown. So one of the most common mistakes people make when working with these types of things is they may misspell something. For example, we're looking here at the attribute name descriptor. If you misspell that description, for example, you try to edit this, then that's going to give you an error. Now, next up in our list of attributes is point type. And for point type, let's take a look at a couple of slides in. This is the variety of point types that we support. By default, all pi tags are float 32s. That's a single precision real. We do support higher resolution, but that does come at a cost. It's going to be twice as large on the number component is going to be twice as large on disk. We also support something called a float 16, but that's mainly to maintain compatibilities of older versions of Pi. And we support integers, and we also support digitals. Digitals would be discrete values like on, off, open, close, etc. Let's take a look at a digital tag. I'm going to switch over to a copy of Excel, and here's a Pi tag called CDM158. As you can see, it's got different values they look like strings, but in fact we're storing them internally as integers that are mapped to a digital state table. So compare that to, for example, a real tag, a real float 32. That would be showing us as a single precision real. So the comparison here is, of course, this is going to be a finite number of string entries, and that's what we have for support for digitals. And in addition to those, we also support string tags themselves. For operator comments, for example, we do support something called blobs, binary large objects. Not very big at this point, only 976 bytes, but we do plan on supporting being able to associate large files like multimedia files like pictures or WAV files or something with Pi tags. And then finally, we have timestamps. You can itself store a timestamp itself that will have a timestamp that represents the time at which you stored that timestamp. So these are the different types of points that you can create in Pi. The 0 and span are used to specify the overall range of the Pi tag, and that does have implications in a couple of applications. For example, with a 0 of 50, that means the bottom of the range is going to be 50. The span of 100 means effectively we go from 50 to 150. Now, for float 32 tags, there's really no implication in the archive for this. For float 16 tags, this actually will limit the values that can be stored in the archive. About the only thing that this affects for other types of tags is the displays that you'll see in Process Book. So for example, if you take a look at this display in Process Book, if you notice this particular tag, CDT158, we're currently looking at this using an auto-scaling function. If you look at auto range is turned on. So we span from whatever the current values are for the y-axis. If we switch over and make this database, then you'll notice we're simply going to pick up that 0 and span. There we go. We're picking up the 50 to 250. We're picking up that 0 and span from the Pi tag. If we were to look at the attributes of this tag, you notice the 0 is 50 and the span is 200. And perhaps the easiest way to demonstrate that is to just go ahead and select this trend and use this little binoculars here to indicate we're going to look at the tag attributes. And if we look at the 0 and span, we'll see the 0 is 50, the span is 200. Now this affects a variety of different things within our client applications. Of course, in RT Web Parts, the visualization tool for the thin client on a web, we have that same effect. And one perhaps more subtle is that if you were to take this object right here and make it into a multi-state and make use of that tag CD2158, notice that the number of states that you choose are going to be split among the numbers in the range. So if you look, this goes from 50 at the bottom all the way to 250. That is something that will definitely be limited if you don't set your zero and span properly. Occasionally we find folks who leave the default of 0 to 100, since the Pi system will store something beyond the top of the range. Well, when they go to use multi-state symbols, they're disappointed because they cannot go beyond the range that's specified in the database. So be careful of that.